So if you would take a break from Code Academy if you're still working on it, open up IntelliJ. If you already got IntelliJ open, close your project that you have open. So we're going to go back to this screen. Because what I want to walk through first is making sure you know how to create a project and set some things up there for the labs. So once you get it open, you're going to hit Create New Project. We're going to go over here on the left, pick Java. You can see that it's already picked version 13. That's what you should have there. We're going to hit Next. So make sure you're Java 13. Okay. We can, if we want to, we can create it from a template. So if we grab Create Project from Template, say Command Line App, this will give us a good start. We'll want to give that project a name. So for this one, we're just going to say adding numbers. Okay. You may want to put that in your repo. I am putting it elsewhere just for testing purposes. So I'm going to call that adding numbers as the project name. Now what you'll see in the package, it started calling it Hello World. I'm going to change that. But typical rule for putting in the package name, usually when you're writing Java programs, what you start with is the domain name of your company, right? So if I was working for, let's say, Enterprise, it would be enterprise.com, right, as my website. Well, what you do is you flip around that domain name backwards. You put the TLD, the last part of that first, and then the second part of it is like the main domain name. So if it would be com.enterprise. That's usually how you start. Now, that's not a hard and fast rule. You don't have to start that way. But when you go to deploy Android apps and such, note that what you come in here as your package name is actually going to be the name of your package on the App Store. So it needs to be unique to you, which is where we usually put that company name in there because that helps make it unique to you. I could leave it as just adding numbers. That's a valid package name. But then that means that I would be conflicting with anybody else who's chosen that name, right? So I might put that in as edu rankin because that's the org here, but I probably also want to put in my name in this case. So I'm going to put it edu rankin.prsmith. General rule, as you're going from left to right, it's going from less precise to more precise is generally how we do those package names. So it would be like your student name there would be the third thing. And that will make it unique to you. So edu rankin prsmith, adding numbers. That's the name of my package. And actually, typically, that should also be lowercase. Simply because we reserve uppercase letters for when we're actually getting into class names. So does that make sense? So let's go ahead and finish that. It's going to go ahead and start creating this project. You may see a tip like this come up, tip of the day. Completely up to you. If you don't want to see those again, just uncheck the box and hit close. Okay. So by creating it from that template, from the command line template, it's already created a class called main, and it's already put a main method in there for us. If we looked on the left, you do see that there's this project pane. If I expand that, you'll see that there's two folders in here. So there's the idea folder, which is files specific to the IDE. You don't need to do anything with those files. Same thing with IML. IML is it's tracking what you've got. what you're using as far as what version of Java are you using, where does it start, etc. So those we won't need to work with. All we're going to work with is what's in the source folder. So if you look in the source folder, src, you'll see that it's got the name of the package, and you'll see it's kind of showing it this way, edu.rankin.prsmith.adding numbers. Okay, now this is the way it looks in the IDE. Okay, that's not the way that it actually looks on your file system. Okay, so if I were to open this up, let's see, show and explore. So I'm going to right click on source, go show and explore. If I actually look at it on disk, what you'll see is there's an edu folder, a Rankin folder, prsmith, adding nums. So when you're looking at package names in Java, note that what you're seeing separated by dots is actually going to be different folders on your file system. Does that make sense? So actually different folders. So it's going to be slashes on your file system, but it's going to be dots in Android. Okay. So there is sort of a tree structure, if you will, to how those are arranged. And that does come up. It is relevant sometimes how those packages are related. When we get into access modifiers, that does kind of matter. So we've got this main file. Let's start by just making it do the simple hello world that we had yesterday. So I'm going to change the code in the middle there, system.out.println. We're just going to tell it to print hello world. Okay. Once you've got that in there, the way you get your program to actually run is this little arrow up here. So you can click on run up at the top. Once you do that, you'll see it should pop up a little dialog down here at the bottom, and you can see it's under run. It's showing you that it's given this output of hello world. Okay, so that's all you have to do to get a program to run with IntelliJ. Okay. Now, let's say we want to enhance this a little bit more. If you've gotten far enough in the tutorial into the Codecademy tutorial, you'll already know about the scanner class, right? So we've used system out, right, to, huh? Okay, it didn't run into there? Okay, well then we'll explain it right here. There's a W3 Schools page about it. So system.out is how we write things out to the console that we want to show to the user, but we're going to use system.in to read things in that the user types in. So we can write things out and also read things in that they type in. Scanner gives us a nice wrapper to work with that input stream. Otherwise, we'd have to deal with the input stream as a series of bytes, and that's not very user-friendly. So what instead Scanner gives me this ability, it wraps around the system in, and I can say, okay, give me the next line that user typed in, or give me the next integer that they entered. So it deals with a lot of things for us without having us to write that code. So if we look at here, you can kind of see an example of that. So I'm going to create a new scanner. I'm going to give it the system in because I'm telling it where to read it from. The reason that we have to give it that input stream is that it can actually work with any input stream. In fact, you can actually use scanner with files. For instance, you can use it with text files to read in that. Let's say you want to write a CSV, scanner can actually do CSV type reading. So it's pretty flexible. Now, it is in the java.util package. So remember, Java lang is included by default. Anything in Java lang I don't have to import. But if I want to use something that's not in Java lang, I have to tell the system, I have to tell Java, where is that class? Okay. So anytime I use a class like that, I have two options. I can either here write the full name, java.util.Scanner, or I can put it up here. Okay. That's usually the quickest way to do it. So let's go kind of follow along with this. I'm going to go back to Android, go back to idea, and we're going to comment that out, and we're going to start writing in some code. So I'm going to create my scanner first. So my scanner is of type scanner. It's gone ahead and included that. It's equal to new scanner system dot in. Okay. So simple as that, we create a new scanner. Okay. Now I want to tell the user what I want them to type in, right? So maybe right now I just want them to enter their username, right? So I'm going to say system.out.println. And I give them some sort of message to tell them what I want them to type in. So I might say, please enter your username. Right, so that's going to print out a line to the user so they know what they need to do. And then we want to read that data that they just typed in from the console. So I'm going to say string username is equal to my scanner dot next line. Okay. So next line says let the user type in a line of code, a line of text, and then return that to me. In the meantime, this will actually block your program. Nothing will be happening while it's waiting for them to enter that line. So your program will actually be paused.
So that scanner thing, you have to put that in use scanner.
Yes. Yeah. So we have to create a scanner object anytime we want to use it, and we'll have to import it as well. So both of those two things will have to happen anytime you want to use scanner.
So is a scanner, is it open a string to the console basically?
So the stream to the console is already open. It's system in. System in is the stream to the console for the user typing in things with their keyboard. So that's already, system in is already connected to their keyboard. Scanner just wraps it and gives us in a way that's nice and easy to use, if that makes sense.
What other, so there's system in, like, could you also listen for different inputs?
So, yeah, if we wanted to read from somewhere else, I would give it a stream from somewhere else. Okay. Right? So if I wanted to read it from a file, I wouldn't put system in here. I would put the file stream there instead. And I'd have to do a few things to get that open. But I would put a file stream in there instead. Cool. Or if I was reading it from the network somewhere, that would be a socket connection, and it would still be a stream. If I wanted to read something from a Bluetooth device, well, I would get a stream for the Bluetooth device, and I could read stuff in from the Bluetooth device. So it's pretty flexible because there's a lot of different ways to get a stream.
Cool. So that I just take that. That's what that parameter is. Just a string.
Yep. System.in is the standard input stream. Just like system out is standard out, we have standard in. Okay. So I've read the username in. Then I want to actually do something with it. So what I'm going to do last is just print it out to the console. So I'm going to say system.out println, and we're going to say hello username. There. So say hello, their username, followed by an exclamation mark. So if we execute that, take a quick look at what that looks like now. So you'll see the output down here says please enter username. You'll have to click into there to actually start typing in stuff. So I might say my username is Paul. You'll see it could kind of show up in green down there at the bottom. I'm going to hit enter, and you see now it's run the rest of the code. But you also notice, again, notice that it didn't get to this line until, it didn't get to finish this line, this next line, until I had typed in and pushed enter, if that makes sense. So it blocked, as we would say. Next line is blocking. Okay. So pretty simple. That gets us started on, okay, now I can take data from the user. But more than likely, I probably want to take some data to the user that's not just text, right? So that will give me a text string from the user, which I could actually use that to do everything. But sometimes I want to get specifically a number from the user. Okay, so let's look at how I might do that. So maybe I want to get their age. So system.out.println and I want that to be an age. Now, I have a few ways I could do that. I could do this in 2 steps, and I could say, read the line from the scanner, and then I could try to parse it. So I might say int age is equal to now integer dot parseInt, and parse the text that they gave me. So I could do that as 2 steps, and sometimes you do want to do that as 2 steps, simply because if I do this way, it gives me that flexibility to handle any errors that might happen with reading the input. So say they entered something that's not a number, I'm going to need to do that as 2 steps.
Is there a try parse like we said in C#?
There's not. So you do have to do a parseInt and then catch the exception if you have that case. But no, there's not. And the reason that there's not, remember try parse in C# uses an out param, which is also another way to do pass by reference. Java does not support any sort of pass by reference. So there's no out params, there's no ref params. That was something that originally existed in C++, passing by reference, and was removed because it tended to cause a lot of headaches. So they got rid of that, which also means that now we don't have that tool to be able to do things like try parse. So that doesn't even exist in the language. Okay. So that's how I could do that. I could do that as 2 steps, but more often than not, just to keep it simple, the other way you can read that in is you can say int age is equal to scanner, and instead of saying next line, I'm going to say next int. Okay. Now next int does have some interesting behaviors, so we want to try that in a second. I am going to put a line here at the end to print out the age. System.out.println and in this you'll see, just like how C# works with the plus sign, if you add a string and a number, you end up with a string. You end up getting concatenation. Remember, if I add 2 numbers, I get a number. If I add a string and a number, I get a string. If I add 2 strings, I get a string. So you get concatenation if there's a string involved, or you get addition if they're all numbers. Okay. So let's say we give this a try. So I'm going to run this again. I'm going to type in PR Smith, and we're going to type in age, and you'll see it's gone and read that. Okay. Now that's assuming that I pushed enter when I typed in my age, right? Here's a little interesting thing to note about how nextInt works. So I'm going to try this again. So if I type spaces, next line doesn't trigger, right? Next line only gets triggered once I actually hit enter, okay? But with the age, oh, they may have changed it since I last tested. That's fine. Never mind that. So they're working the same. It used to be that if you put a space in there, that it would immediately go back and read it instead of waiting for enter. So that's good. So that's the other way that you can read it in. You can use nextInt and potentially catch exceptions if something happened there as well. Okay. So that gives us a way of kind of, you can see I can give it strings, I can give it numbers, right? So maybe I want to create another program now that will then say, give me a sequence of numbers, and I'm going to add them all up for you, right? So let's say I make a new class over here. I'm going to right click the package there. I'm going to say new Java class. And we're going to call this adding nums. Okay. Now when I've created this new class, you'll see that it won't have a main method in there, right? I have to go create that. So let's go put that in again, just for remembering how that looks. So public static void main. We need to take an array of strings. So again, I do need a scanner. So I'm going to create one. New scanner system.in. Okay, so that way I can accept data from the user. Okay. Now I'm going to say write out a message system.out.println. Okay. And let's read that number in. Now let's assume that they want to give us something that's not necessarily just an integer. So I want to read in something that's a double. Just like there's a nextInt, you'll see there's a next for each of the different data types that exist in Java. So if I want to say get a double, I'm going to say next double. So now I've created this new class, right, with its own main method, right? Let's try to run this program and let's see what we get. Note that when I try to run it, it's still saying, please enter your username, right? So it's still running that other main class that we initially had created, right? So we may want to set things up where I can actually decide which class to run when I tell it to run. So if I go into the run menu up top, I'm going to go into this run ... You'll see that there's only one configuration here right now, right? If there was more than one configuration, I could pick the others. So I'm going to say edit configurations. I'm actually going to create another configuration in here. So if I if I go over here, I'm going to say add. We're going to say add a new application. This one is now going to be, remember we called it adding nums. So adding nums is the name of the class, the main class. And you set that there. If I had any command line arguments I wanted to give it, remember there's that string of args that the main method takes. I could actually put those here and it would start that with those args. So if I wanted to start with 1, 2, 3, I could do that right here. I think the big thing, adding nums. Yeah, there it is. That's where I want to change it. So adding nums. Yeah.
You only have to change main class and name. Right?
Yep, that's really all you have to change, is change the main class and the name of that application.
So will we do that every time we make a new class?
You'll want to do that if you have a new program, effectively, right? So you create effectively, these are now separate programs, right? So we have this one, which we could rename to maybe a better name than main, but effectively, these are two different programs, okay? So when I run now, I can do run ... and I can actually pick from either of those. So I'm going to say adding numbers. Adding numbers is not around run parallel, so we're going to stop the other program running, and now we're running. So now it says please enter a number. Great. I type in 3.5, and it's done. Since we haven't done anything with the number yet.
Can we just right click it on? And it goes to, like if I go back to, if you go back to the main,
I think you may right click that. Yeah, run adding nums. I think you're right. Run main.
well,
So you stop and rerun.
It's 2 clips versus. Hang on, try going to just like on the menu bar. When I click run the first option says run.
Right, so there's a run main here.
And I think it knows.
See, it doesn't.
Defaults to the last one you used.
Yeah, I believe that's all it's doing is defaulting the last one you use. So you may need to set things up like that where you have a different configuration for each of your programs, is the point. Other than that, you can create them as completely separate projects, but that's probably a lot more work than it's worth as to make 20 separate projects. You probably just want different classes. But that way, either way, that way the code for your different programs is separated, so it's not all in one place. Okay.
So
now,
you want 20 different configurations for that lab?
Yeah.
Okay.
Yeah.
When does that lab do?
When does that lab due? I believe I'd have to go back and look. I think it's due Tuesday.
It is Tuesday.
It is Tuesday. So you've got some time to work on it. So this is kind of where you're going to start with that. So let's say I want to go through here. My end goal is I want to allow the user to enter as many numbers as they want, and then eventually I want to give them the sum when they're done, right? So given that we have already here, what can I do to accomplish that? What's maybe my next big step? Add another number? Okay. But I want the user to be able to type in as many numbers as they want. A loop would be a good idea. Graham, you had a hand up? Yeah. So I remember from C#, what loops do you remember hearing about? What loops exist in C#? There's a for. There's what else? There's a do while and a while. So for really, which is for each, right? So for each works when I already have a list, which I don't have that. Okay, so that's not a really good candidate. For typically I have a counter in there, right? Maybe that would work. Maybe it won't. Okay, so a while loop is an option.
What's the goal here? Like what
I want the user to be able to type in as many numbers as they want, and then at some point we're going to stop and give them their sum.
So what do we want to do while?
Probably want to, well, do we want a while or a do while, right? So what's the difference between a while and a do while?
The do while will always run because there's no checking for the runs.
So you mean it'll never end, but it'll always run?
No.
So for the while loop, the initial check is at the beginning of the loop, whereas the do while is at the end of the loop. So the do while inherently runs at least once.
Exactly. So that's the thing. So do while always runs at least once, and while only run 0 more times, right? So in this case, how many minimum numbers does the user have to enter? Well, 1, right? The user has to give me at least 1 number. So it's reasonable, and this is a good place to use a do while because I know that the user wants to give me at least 1 number. So the way I'm going to hook that up, we're going to say do at the beginning of this. I'm going to say end this here while something. Okay. Now we have to give it a condition, right? We have to give it a condition. If I just say true here, well, then it's going to run indefinitely. It's never going to end, right? But I want to give it some sort of criteria to say it should end under these conditions, right? So what's a good kind of way for the user to say that they're done entering numbers?
They could type out done or some other message.
Done or some other message. Okay.
Like after you write, please enter a number, you can put like parentheses, like -1 for complete or something, and then check if they're in.
Right. So really what we're saying is effectively what we call a sentinel value, right? So that's called waiting for, we're looping until we see that sentinel value. So if I say done, well, that's text, right? So inherently, if I want to read that, I'm going to have to say next line, right? If I want to read, I could do it when you type in done, but inherently, I'm going to have to do next line every time and try to parse it, right?
Since the purpose of this is addition, we could have it so that if they type in a negative number.
So that could be the way I can do that. So the point is I could either have it be textual, like you were suggesting, like typing in done or exit, or which in case I would need to be using next line in each iteration, or I could have a sentinel value and say if they type in -1 or a negative number or 999, whatever number I pick, we say if they type that in, then we're done. Okay, I'm going to pick 0. I'm going to make it easy and pick 0 and say if the number they type in is 0, then we're done. So if num does not equal 0, then we're going to keep going. Yep. Right. It's not in scope. So because once this num is only declared inside of the loop, I need to have it here where I'm doing the actual check, which means I need to declare the variable here and assign it inside the loop.
That was in C# too.
Huh?
Is it like that in C#?
Same thing in C#. Same thing in C#. The only really new thing here between C# and Java is the scanner. So we've got to move the number out there so we can declare it and we can have it. And then let's say I get done with that. Eventually I want to type out the sum, right? So how am I going to do that? I'm going to probably do system.out.println total is, well, total is what? Is the total the number?
No. Another variable.
I need another variable, right? So if I just used num here, that would just be the last number that they entered, right? It would just be the last number they entered. So I do need another place to keep track of the sum. Okay. So that's what I want to put at the end, is the total is sum. Okay. Now, I do have a little bit of a problem in the sense that this is never initialized, right? So if in theory they didn't enter any numbers, they enter 0 right away, you know, we would have a value for sum. So I need to initialize it to something. Okay, so a logical place to start that is start the sum at 0, right? Start the sum as nothing's been added. Okay. Now I also need to make sure that sum gets updated, because if I leave it as this, the sum's always going to be 0 at the end, right? Because I've never changed the sum. So what do I need to do to change that sum? Sum plus sum?
Sum plus num.
Plus num. Okay. So do I do that here? Sum plus num? Yeah. Plus equals, right? Because I need to actually change the value of sum, right? I need plus equals, which effectively, if I say plus equals, that remember that shorthand for sum is equal to sum plus num, right? So I need that, not just the expression, but I also need the assignment. And we would call sum, in this case, an accumulator, right? Because it's accumulating these values that I'm entering as I'm entering them. Okay. So if we run through that, let's say we execute this now. Stop and rerun. Okay. So now if I type in 1, 2, 3, and then type in 0, I should get, hey, my total is 6. Okay. Now, one thing worth noting here, I haven't told it how many decimal digits to round to, right? So if I left this as is, it might potentially have some rounding error and might have a very long sum at the end, right? So I definitely want to tell it to round to a certain number of digits, right? So you remember me talking about printf yesterday. So that would be one way to solve it. You can also solve it using string.format. Okay, so let's do both of those so you can see what that would look like. So if I was going to use printf, what kind of thing is this sum? It's a double, right? So because it's a double, I'm going to do %f. And I want to tell it how many digits. So let's say .3. That will round it to 3 digits. So in here, I'm going to say my first argument is the format string, the printf. Total is blah, blah, blah. Percent is $ dot 3f. Oh, I got rid of my f. I might want to put a new line at the end there. So then whatever inputs I give after this format string, those are going to replace the format specifiers here in the order that they appear. So because this is the first one that shows up, well, that's where sum is going to go. So let's give that a real quick try. So 1, 2, 3, put in 0 to end it, and I'm getting a total of 6 still, but now rounded to 3 decimal places. Okay. So that can be one way to do it. I also might want to do, sometimes especially when we get to Android, we will not be working with the console. So we may still want to do formatting even when we don't have printf at our disposal. So we can do that with string format, and that would look a little bit like this. It's very, very similar, but just a slightly different call. So I'm going to do string.format. And you'll note that I'm calling string.format inside of that print line. But it takes the same arguments. So string format, I give it the format string, and then I give it any values that I want to substitute into there. So that string.format is something that we will still be able to use when we get to Android, whereas printf is something that will be going away because we won't be using the standard input or the standard output in Android. Okay. Does that help you maybe get somewhat in the right direction for some of the labs? I hope get a few things kind of understood for how to work with the language, how to work with IntelliJ. That's most of what you're going to need to know about working with IntelliJ, is how to create a class, how to create a, set which main class runs. That's the gist of that there. Now, as you're creating the problems, let's go look real quick about that. I'm going to go ahead and save this and close it. Close the project so I can kind of show you what I want for the actual lab assignment. Okay, so I'm going to create a new project here. Again, I'm going to create it as a Java 13 project. Let's go ahead and actually let's skip the template for the moment and see what we get. So if I'm going to call this console programs,
Where do we put this at?
just put it in your projects folder under your repo. Okay, so I created this project, called it console programs. Did I? No, I didn't. Okay. So in there, I want to create a new, let's say I want to create a new file. Let's say maybe for this purpose, I'm not going to use any packages. I'm going to say new Java class. And this is maybe, I'm going to say this is problem 1. Okay. So I'm going to create a class like that. I need to give it a main method, public static void main. Once I give it that main method with that signature, one thing you'll notice that this little green arrow shows up on the class. So that's telling you that that class has a main method. It's worth noting.
Where did you rename that?
What do you mean rename? If you need to rename that, you just right click, say refactor, rename. But I created it without a template. I didn't use the template. So I just created a new class. So that's basically all I want from you. Don't put them in the namespace. Don't put them in a package. Just have them problem 1, problem 2, problem 3. If we look at the actual lab assignment here, you'll find this on inside Rankin. So there's 25 problems or so out there. I only want you to do 20 of them. And just if you number them that way, then I can know which one's which. Any questions on that for the lab assignment? Any questions for how to set that up now? Okay, so you're just going to have a different class for every project.
So if we run it,
Yep.
are we just gonna like do the same things with the configuration?
Yeah, so if you right click this, you should see like run problem 1 main. And that'll start it up. So that's that intro to the scanner class. So now that we've talked about that, let's hop over to perusal and start there.
I'm still opening the previous project.
Um,
Yeah, I know it's that.
It's not saved. Go to file settings. let's change it on Android Studio, but not here. So different settings. So go to system settings. We'll need to close it out. So let's look at the so you want to go to Perusal. We're gonna log in. You should have your credentials already sorted. And I'm gonna go into our course. So just a reminder, there's a few tabs when you get in there. You should be seeing documents and you should be seeing assignments. Does everybody see that? So documents, if you look in here, you'll find everything that you need. Quick references there. Again, Java is where you want to look primarily for additional resources. To see the actual due dates on things, make sure you're looking under assignments, and that way you'll see them kind of arranged by when are they relevant. Okay, when is this documents due? Now, there's also an option here to save space. It may be already expanded for you, the left bar. If you click this little X, that will collapse it so that you have some more space on your left-hand side. Okay, so let's go open up the quick syntax reference. We're going to look at some of these pieces here. And jump up to Hello World. But I think, yeah, so we've covered most of this stuff already. So just a reminder, you know, typical class starts with public class, yada yada. If you want to put it into a package, that's the first line in the project. One thing to know, if you put in the package as my project, but it's not in a folder named my project, you will get a compile time error. The Java compiler does throw an error if your package name doesn't correspond to the folder that you're in. So that also means when you're compiling it or when you're opening a project in an IDE, you need to make sure you open it at the right root, right? So if I try to run that program that we had with namespace, right, but I try to run the Java compiler directly from the folder that the Java file's in, you would say this doesn't work because the package name doesn't correspond to the folder. Does that make sense? So that does matter. And there is some instructions, I think, on there as far as how to do it without it. If you do want to run the Java Java commands that I showed you yesterday, more than likely it should work already, but just to verify that it does, if you open up your environment variables, okay, do be very careful as you go in here because you don't want to change anything. But if I click the path variable and go edit, one of the things you'll notice, you see C program files, Java, JDK, that is already in my path. Actually, I need to change that to 1301, I think it is. Let me check that real quick. Okay. So Java Home is again kind of telling it where it is, and that's used for most of the IDEs. I don't think the IntelliJ really pays attention too much to that, but okay, so 1301 is the one I really want to have there. So edit. So the way this path variable works, which is really special, it's a very special environment variable. is that when you tell Windows to run programs, especially when you tell it to run programs over the command line, it will typically look first in the folder where you're running it for a program with that name. And if it doesn't find the program by that name in the current folder, it will then go through the path in that order and look in those folders. So as we can see here, it's going to look under Windows apps if it doesn't find it, and then the JDK bin folder, etc., etc., etc. So that tells it, if you don't find Java C, go look for it in this bin folder.
So I don't have that. Should I add that in here?
You may or may, you probably don't need to add that unless you wanted to do things over the command line. But to do things through IntelliJ IDEA, you won't need that. Right? That would only be if you wanted to run the Java, if you wanted to directly run things through the command line. Okay. So that's because I have that in my path is why I'm able to just type into the console and say Java C or Java. And it will find those commands. Otherwise, it would say, hey, I can't find Java C. Comments we looked at a little bit. You've already seen some with. They're basically the same thing as you've seen in C#. So a // is a single line comment, and a /*, and then a */ is how you write a multi-line comment. They also have something in here called java.comment, where you'll see there's an extra star in there. So it's /*, ends with a //. That particularly is what generates that API document that I showed you yesterday. So the Java APIs, they're a bunch of Java classes and they're littered with these java.comments, and that's what actually generates those websites that you see that I pointed to you yesterday, is these kind of java.comments. I don't need you to write any of those this semester. I don't need you to write any of those java.comments, but just to know that's what they are. And if you're looking at any other code or looking at the library code in Android, that's what that is. So there's a tool that you kind of run your code through, and that ends up generating a website, basically, because it'll strip all those comments off, the java.comments. And typically, the two places that you put those java.comments, you only really put them two places. You either put them at the top of a method, before the method signature, or you put them at the top of the class. And so you get the class definition, which shows up at the top, or you get the individual method definitions and such that show up with it. Okay. Similarly, if you put it on top of a constructor, it would show up as the documentation for a constructor. Okay. So the data types well, obviously we won't be able to work with variables. The data types in Java are broken into two kind of categories. So first of all, we've got the primitive types, and then we've got what we call the reference types, right? So the primitive types are basically all our numbers, right? So byte, short, int, long, right? Or float and double. There is no decimal type in Java. That only exists in C#. And then there's also char for characters, and then there's another type called Boolean. Now, this is one thing to remember because you are transitioning over from C#. Remember in C#, that the type for Boolean variable is bool. In Java, it is Boolean. If you don't write out full Boolean, it will say, I don't know what value type for. That's just one of those gotchas. Other than that, they behave the same way. They're just a different name. But there is no difference between them. What? Yeah, strings will get you two. Strings fall into the reference type category because strings are always objects in C#. So they always are going to start with an S, an uppercase S. Whereas in C# you could put it as a lowercase s or an uppercase s. It would be the same thing. It has to be an uppercase S in Java because name conventions are kind of important, and they're pretty strongly enforced. So that's where we're going to have that as a reference type. Now, other things that fall into the reference type bucket. So really, under the reference type bucket is going to be anything that's an object, right? So that includes strings. That includes type object, which is the subclass of every object in the system. And then any other classes we have. They're also reference types. The other thing it also includes is arrays. So if I want to create an array of integers, that is also an object. Okay, so it follows all the same rules as objects do. Okay. Or if I want to create an array of strings, an array of bools, all of that is objects. So when we declare variables, it looks the same way as it does in C#. We give it the data type and then the name of the variable. And if I want to give that a value, I'm going to put that single equals, which is what we call the assignment operator. Remember, double equals is the equality operator, single equals is the assignment operator. Okay. I can also potentially create more than one variable at the same time using a comma. Don't use that. It's much better. It's always better to do it as on separate lines. Basically, what that comes down to is the way it plays with source control. Source control, as a general rule, works on a line-by-line basis. When you're merging code between two different developers, it's on a line-by-line basis. So by keeping the variables on separate lines, you work better with different developers. If you write code like this, you'll find out if two developers edit that same line, you're going to have a mess. And you're going to get a conflict which you have to manually untangle and figure out what did they do and what did I do. So use the other type. Okay. We can also print things out as we've seen. So system.println will simply print out the thing that we told it to print. And a line terminator, if I just call print, it won't add in that line terminator. Okay, so if I want things to happen all on one line, I want to do multiple prints and maybe avoid a concatenation, well, I could write it out as just print. You've also seen printf if we wanted to do formatted printing. Okay, so for the integer data types, we've got byte, short, int, long. They're all the same types as you've seen in C#. The limits of the upper and the lower, they're all the same. Byte is 8 bits, 16 bits, int is 32, and a long is 64. Now, one thing to know, they're only signed. All of those numeric types in all the 4 of those numeric types in C#, they're always signed. In C#, you did get the option of signed or unsigned types. Remember, unsigned types don't have negatives. That's not an option here. And that can become a little bit of an issue when you're working with other programs that may have been written in C# or C++ that have unsigned numbers. So that can be a little bit of an issue sometimes. And once you get into working with things over the network. So just a fair forewarning, that does exist out there. You can also define your constants in things other than just base 10. So I could say 7 in base 10. I can also do things like this, 0xf, which is going to be in base 16. That does come up and does become helpful in certain cases. Like, let's say I wanted a HTML color code. Remember, those are base 16, right? So there are things like that that may occasionally come up. But we really don't use octal or the binary representations. I won't ask you to do anything with those. With big numbers, you are allowed to add in underscores like this instead of commas to kind of separate it out. But again, that doesn't happen too often, but it is there if you need it. Floating points, one thing to remember, just as in C#, by default, floating point numbers are in doubles. So if you want it to be a floating point number that's a float, that constant needs to end with an F. Okay. Similar kind of thing when you're writing constants for these other data types, you may need to end this for long with an L or an S. I think there's another way. I can't remember if there's a shorthand for byte, but it might be B if it does exist. But long is one of those things that is there, so you may need to have an L. Fair forewarning though, if you're going to create a constant that's a long, use the uppercase L. You're technically allowed to use a lowercase l or an uppercase L. Problem with the lowercase l is it looks like a 1 in certain fonts. So always use the uppercase L if you're going to have that suffix. Because the uppercase L, you can always tell it's an L. The lowercase l, you can't always tell. I had one of the developers I worked with put in this constancy, lowercase l, and in the tool that we were doing code review, it looked like a 1. So I'm like, I can't, what's going on here? Something's not right, because that shouldn't be 101, it should be 10. So, yeah. Char data type, remember strings you start with double quotes, characters or single quotes. So remember a character is just a single character. Characters in Java are always represented in as UTF-16. So a char data type is actually 16 bits long. Okay. If we remember Unicode, all the Unicode characters are officially they're 32. So there are cases where two characters being next to each other can actually be a whole character, if that makes sense. So we kind of call those multi-byte characters. And you do see that sometimes when you're working with strings, especially, this is more specifically if you're working with strings that are not from the US, namely Chinese characters or Arabic characters is where more likely you're going to see something that's more than one character long. Booleans, again, the big gotcha is that it's Boolean and not bool. Variable scope works just the same way you're familiar with. It's going to be block scope, whatever block you define that variable in, that's where it's available. It's not available on any lines before it's been declared. You can also add in anonymous blocks. This is actually something that's also available in C#, but isn't used necessarily all that often. I can put a block around here and say, hey, this variable isn't accessible outside of there. And that may seem like kind of a weird thing, but let me actually show you where I might use that with one of the programs we just wrote. So if I go back to the adding numbers project, one thing you'll notice I have this num variable, and remember I had to extract it out. Well, now this num variable is accessible anywhere in the program after that point, which is not really a good thing because it's not really something I want the rest of the program to use. So I might actually take an extra bit of curly braces and put it there so that num goes out of scope. Does that make sense? So you can't accidentally use it later on. That happens, things like that happen often enough that it's something that's worth having in your toolbox. It looks kind of weird to have an extra set of parentheses in there, but what you're doing is you're saving yourself from accidentally using a variable like that doesn't really have meaning at this point. You're also allowing the system to go ahead and, because it's gone out of scope, take that memory back, right? It's allowed to take that space back now that you've told it that I don't want to use it anymore. Okay. Now operators, let's look through these operators. All of them are pretty much what, again, same things, plus, minus. multiply, divide, modulo. Don't forget about modulo. Just a reminder, modulo gives us that remainder. Okay, so that modulo operator is actually seems like an odd one, but it's useful for a lot of things. So don't forget that it's there. One thing to remember too, if I'm dealing with math and integers, I am going to get, it's going to go ahead and do things with integer rounding, or it's going to round down. So if I say 3 divided by 2, that doesn't give me 1.5. That gives me 1. So if I want it to divide it as floating point numbers, or do math with it as floating point numbers, I need to tell it to be that it is, right? So if I said 3f divided by 2f, I would get 1.5. As long as one of them is a floating point number, it will convert the other one to a floating point number automatically. So that's what they're doing here. But here they're explicitly casting. You could have just said 3f. Okay. Assignment operators, we've seen that as the single equal. There are all the shorthands you're used to. So you've got plus equals, minus equals, etc., etc. You just add the symbol and the equal sign, and that is your combined assignment operator. Okay. So we've also got plus plus, minus minus. Both things will be inherited from the world of C++. Whether or not you remember it, remember that there is a difference between plus plus at the beginning and plus plus at the end, right? So if I do plus plus x, then I'm doing the increment before the rest of the expression, rest of that line of code happens. If I put it at the end, we call post increment, that's going to happen after the line of code executes, right? So that does mean that I get different outputs when I do something like this. Go ahead and put something. So if I say int x is 5, and then want int y is equal to plus x. So here it's before, it's going to do the operation before the line of code happens. So it does that first, x goes to 6, and then y ends up with 6. So in this case, I'm going to end up with a y of 6, but if I do it afterwards, I'm going to end up with a y of 5, because it's going to do the assignment and then do the add. That does come up, and that's something to be aware of. The safest thing to do is, for as much as you can, don't do an increment on the same line that you're doing an assignment. That's kind of the safest way to get around it, because then you know for sure what's happening. If that makes sense. Make this 2 separate lines instead of trying to do it all at once. Okay? That's the easiest way to keep your code readable. But there are cases where you may want to do things like this all on one line. And they usually come up when you're dealing with arrays or things like that, where you're dealing with groups. Okay. Comparison operators, again, same thing, no change. Equals, equals, not equals, greater than, less than, greater than or equal to, less than or equal to. There's no fancy triple equals or equals equals exclamation mark like you might see in JavaScript. Those are all of them. Now, there's one very, very important thing to know about the double equals in Java, okay? Because the double equals does not work in Java the same way that it works in C#. Okay, it does not work the same. So in Java, we have the benefit of something called operator overloading, where the code is allowed to change the meaning of equals equals depending on what 2 things you're comparing, right? So in C#, the operator for comparing 2 strings, that equals equals, has been changed, okay? The default for equals equals is if I've got 2 primitives, well, I just compare the objects, that's fine. But if I've got two objects, I need to compare them somehow. So by default, that equals compares where they are in memory. Okay, where they are in memory, not the actual values of the objects, right? So what that can mean is I can have code like so. Let's say I say int, oh no, so let me say string x is equal to new string, or actually let me do that way. So this is foo string y is equal to so conceptually here, the data in x and y should be the same, right? I start with all lowercase foo, or I take all uppercase foo and make it lowercase. Now they both have all lowercase foo in them, right? The difference is going to be that these two strings are stored two different places in memory. So if I were to write if x is equal to y, that's going to be false. X is not equal to y. That worked in C#. It doesn't work in Java.
So with strings, we always want to use the dot equals when you're
You
comparing.
always have to use the dot equals, right? You always have to use dot equals. So let's visualize what this looks like in memory. So I've got my variable x, right? And I've got my variable y, okay? Now remember that string is a reference type. It is an object, right? What did I tell you about pointers yesterday? We said the data is not actually stored in the variable.
The variable stores where it's stored.
So, yeah, it just tells us where it's stored. Okay, so let's say I have 1 here and 2 here. So this points to location 1, which stores foo. And this points to location 2, which also stores foo. So the data over here is equal, but the actual values that are in x and y are different. So when I do equals with objects, I'm comparing these references.
What if you put string y as lowercase foo? Is that calling not to lowercase, but it's still
It I have to check it for sure, but I think it will, as it turns out, it would give you true. Because they would end up being in the same place in memory. Because there's some magic as far as when things get compiled, any constants that you have, like I have a constantly declared string, it's going to put that someplace in memory. And if it sees that more than one place, it ends up pointing those at the same place in memory. So it might stitch it together. If I just wrote lowercase foo here, it would come out as equal because they would end up being the same place in memory.
So I'm guessing equals works like it's the same in C# as it's a method of the object class that gets inherited.
Correct.
And so string is pre-made and overrides it.
Right. So the correct way to write this is x dot equals y. So we call the equals method on one of the strings and pass it to the other.
So when would you use that double equals before to just compare?
So you only use the double equals with primitives as a typical rule. If I have a reference type, I'm always going to use dot equals. If I have a primitive type, I'm going to do double equals. Okay. Now things get interesting when you're dealing with some of these types. So we'll get to it later in this book, but there's something called boxed types. and box types are reference types, and they behave fairly interestingly. I don't want to get into those right now, but there's some weirdness once you get into that world.
When you say they behave weird, they usually say something.
Yeah, I kind of wish box types were not a thing in Java, but they are, and they're used a lot. So you do have to understand how they work. So this is something that's going to bite you a lot, and it's going to bite you hard. So just be forewarned, that's what your problem's going to be. You have to make sure that you're using the equals method for anything, anytime you're dealing with objects, and use double equals anytime you're dealing with arrays. Now, one thing in there, so equals is implemented for strings, equals isn't implemented for arrays. So if these two things were arrays, that still wouldn't work. Just fair forewarning, there's no equals that's implemented on that subclass. One gotcha that you get with this though, okay? So let me change the code a little bit. So string x is now equal to null, and string y is equal to foo. So far, so good, no problem, right? So I've got a null, and I've got a string in the other variable. If I try to compare these, remember we were talking about yesterday about null reference exceptions, right? I get a null reference exception anytime I try to access what that points to, right? So inherently when I call a method on x, I have to access x, right? X is null. So this will throw a null reference exception because x is null. Whereas if I flip it around the other way, that does not get a null reference exception, right? This one I'm accessing y, passing an x. This one will throw an exception. That one will.
I never thought of that.
So typically when you're working with some of these comparisons, you can make your code a lot simpler, especially in cases like this, if you make the first thing something you know that's not null. So if I were to write this as if foo dot equals right, I know this can't be null. So therefore there's no way for that line of code to crash.
Wondering if like that code x is being null dot equals, would that crash in C# because in there strings are primitives.
Strings are still not primitives.
No.
No. Strings are still reference types in C#. They're still objects. But it doesn't crash because, again, there's some magic happening in the sense that when you compare two strings in C#, it actually runs this magic method that runs equals and checks that. So in this case, if you don't know what could be null, right? If we don't know what could be null, the safe way to do this check of equality is I say if x does not equal null. I could say that, and x dot equals y. Right. So sometimes you have to add a little null check in there to make sure that those things are good. Okay. Now, this isn't quite right. Why is this wrong?
to y dot equals x?
Well, what I'm going to tell you is this is, well, no, it's not the same, because if x is null, this doesn't crash. But there's a case in here where it doesn't give us the right equality.
What if y is null?
Y is null. What if they're both null?
Yeah.
Right? So what if y and x are null? Well, if we look through this, this is going to give us false.
Even though it should be true.
Even though it should be true. If they're both null, then it should be true. So comparisons can quickly get into a very sticky kind of world. That's something you need to be aware of. But typically, you can kind of get around with either this solution or that solution, because usually one of the two things you know isn't null. Typically, one of the two things that you're comparing is, you usually know that it's not null. Okay. Doesn't happen all the time, but usually it does. So if we were going to fix this up, we would need to say if, well, we can say if x is equal to null, or y is equal to null, or sorry, this would be and. That'd be one way to do that, if those three things are true. Or x is not equal null, and x dot equals y.
I feel like that's just too much checking at that point.
But effectively, this gives the same results that you would see in C#. That's effectively what the double equals does in C# for you. It automatically converts the comparison of two strings into this.
So we're gonna have to do that every time?
Not necessarily every time. Again, most of the case, it's going to end up where you can just write equals. Because most of the time when you're doing comparison, you know one of the two things isn't null. So if you can figure out which one that is, that'll make your code easier. All right. Okay. So let's resume with this tomorrow. Your homework for sure. I have posted the homework 0-0. All of that's basically based on stuff from this document, as well as some other things that we'll discuss in lecture. So we'll continue with this tomorrow. So continue working, finish up Code Academy, start on those console programs, and be reading through this book. Let me double check. If I bring up Inside Rankin, I can look at the actual dates. Because I remember I debated about which day it was going to be due, but I don't remember which date I decided on. Homework 0-0, yeah, due Friday. So.